Nice. You need something? You came over 400 times. So
I'm glad you finally taken notice to me. All right, it's almost game time.
Mike Weaver was the first one to sign on. Hello, Mike.
Mike is awesome.
And Mick Whitaker.
Mr. Whitaker.
Yeah, he's awesome. Harold Locke.
Mr. Locke, how are you doing, sir?
Awesome guy.
He is.
Cameron Gillis.
Oh, Mr. Gillis, great presentation last night.
Yeah, he did. Stormy Pacific Northwest. Awesome presentation. Chris Larson. Howdy, Scott and Kent.
Oh.
Howdy back, man.
I've been demoted.
It's our nearest neighbor in space. The data we gather from its features can tell us a lot about the rest of our solar system. And through the eyes of the LRO spacecraft, we can explore the lunar surface in all new ways, in fascinating detail. Our tour begins on the western border, where the near side of the moon meets the far side. The enormous feature is a lunar crater, and it's known as the Oriental Basin. Here, LRO's terrain map combines the surface gravity measurements from the Grail mission. This data reveals structure in the lunar crust beneath the surface, giving us a window into the geologic features of the moon's interior. Our next location receives little direct sunlight and has some of the coldest recorded temperatures in the solar system, the South Pole. The highlighted spots signify potential water ice based on temperature readings from LRO's Diviner instrument and reflectance from its laser altimeter Lola. Lola also allows us to peer into the darkness of Shackleton Crater by bringing us its digital elevation model. It's 21 kilometers wide and 4 kilometers deep, but it pales in comparison to the largest known impact crater in the Earth-Moon system, the South Pole Aitken Basin. Sitting on the far side, it's 2,500 kilometers across and 13 kilometers deep. We don't yet know exactly how old the basin is, but it was first seen in the 1960s by spacecraft flying around the far side. As much as we use LRO data to investigate areas we can't see from Earth, we also probe familiar territory on the lunar near side to bring back images with an all-new level of detail. This is Tycho Crater. It's around 100 million years old. Here, the Lunar Reconnaissance Orbiter camera captures the central peak of the 100-meter wide boulder at the summit, the origins of which are still a mystery. Continuing across the moon's near side, we will arrive in an area ripe for future exploration due to the diversity of impact and volcanic materials. It features a prominent crater so bright it's not only visible through telescopes, but also to the naked eye. Welcome to the Aristarchus Plateau. Here, infrared shows the mineral pyroxene in orange and a splash of plagioclase in blue from Aristarchus crater. This region can tell us a lot about the rich volcanic history of the moon. As much as we study the moon looking for sites to visit, we also look back at places we've already been. This is because the new data that LRO is gathering helps us reinterpret the geology of familiar places, giving scientists a better understanding of the sequence of events in early lunar history. Here, we descend to the Apollo 17 landing site in the Taurus Littrow Valley, which is deeper than the Grand Canyon. The path the astronauts took over the course of 3 days is shown. The Lunar Reconnaissance Orbiter camera is even able to capture a view of the bottom half of the Apollo 17 lunar lander,
Wow.
which still sits on the surface, as well as the rover vehicle. These images help preserve our accomplishment of human exploration on the moon's surface. Moving onward, we make our way to our final destination. This location contains regions that exist in permanent shadow, as well as ones that bask in nearly perpetual light. It's the North Pole. Detailed terrain measurements by Lola allow scientists to model sunlight and shadow at the poles over decades and centuries. Sunlit peaks and crater rims here may be ideal locations for generating solar power for future expeditions to the moon. This updated visualization of the lunar landscape stands as a testament to the functionality and abilities of the Lunar Reconnaissance Orbiter spacecraft. And as the mission continues to gather data, it will provide us with many more opportunities to take a tour of our moon.
Well, hello everybody. It's Scott Roberts, and Tyler Bowman, who was called Kent earlier, but that's okay.
I've been called worse.
You can be called a lot worse.
His evil twin.
His evil twin, that's right.
There you go.
So we got to the point where we were wrapping up the second astrophotography contest, right?
Correct. Yes, sir.
And that was a DSLR contest. And
Yes, sir.
we opened it up to any brand of telescopes, any way that you wanted to do this. It was not just an explore scientific type of thing. I think that's totally cool. And now you've got winners selected, but
I want to go over them.
yeah, let's go over them and see what kind of images you have.
You
So
got it. So let me click some buttons here. Let me make sure I'm on the right screen. Yep. All right. Yep. Everybody see that? Party.
that's beautiful.
All right. So obviously we got a nice, looks like a coastal. I'm not sure where without getting into the information, but you got nice Comet Neowise right there.
Super.
And I like the satellite in the back end.
Oh yeah,
That's pretty cool.
right.
And that was from Mark Hilton, who did that one.
Beautiful job.
It was.
Hmm.
Next is going to be a great lunar. Let's see if I can't zoom in a little bit. There we go.
We've been studying the moon a lot lately.
We
so-
have been from Mick Whitaker.
Mick Whitaker.
Mick Whitaker got us this one.
Very cool.
And another beautiful by Mr. Harold Locke.
Harold Locke.
Oh, come on. Zoom, please. Computer, focus. There we go. There we go. That's a great image. It really is.
Yeah.
And we got that looks like the rosette from James Hubbard.
Yeah, that is.
Is that the
James,
rosette?
photographer?
Mhm.
Yeah.
That's a great, that's a good
the
image.
rosette.
That is a great image that he did.
Looks very 3D, huh?
Yeah, it does.
Mm-hmm.
And you got the California,
California. Yeah.
which was done again by Mr. Mark Hamilton, or I'm sorry, Helton.
Mark
Not
Helton.
Mark. Yes.
Beautiful.
And another California,
Wow. Look at that.
done by Diana Herbert. I believe she's part of OPT. I believe.
Yeah, she did it. It's a super job.
It is. It really is.
Hmm.
Now we got Mr. Andrew Corkill,
Yeah.
an ED or an ES 152 and a DSLR using a 9.7 millimeter eyepiece.
Oh, okay. Eyepiece.
There's your rock. I found your rock.
Yeah. I need my rock. I need that boulder, 100-meter wide boulder.
Oh yeah, I'll just throw it on my
Like
shoulders.
The moon. I'd like for someone to collect that and bring it back for me. I'll pay a pretty penny for that.
A pretty penny, huh?
A pretty
Penny. A pretty
brand
penny.
new, shiny, fresh from the mint.
I love this picture from Mr. Aaron Thompson
Uh-huh.
with Mars and Pleiades right there in the middle.
Oh yeah,
That was a good shot.
nice. I remember when that happened. Yeah.
Yeah. And then the good old horse head by Mr.
Classic.
Mark Helton again.
Lane, horse
Mhm.
head.
Horse is very clean.
Oh yeah.
Very clean.
Mhm.
Good picture.
Wow. It must have been hard to pick out the best.
Wasn't easy.
Yeah.
It was not easy.
Yeah.
Here's a flame by Mr. TJ Schultz.
TJ Schultz, huh?
TJ Schultz.
Wow. Look at all that dark nebulosity in there.
That is
There's
crazy.
All kinds of star formation going on.
Yeah.
That's cool.
And this is from Petka.
Another beautiful moonshot.
It is.
Yeah.
It really is.
There you can easily see the rabbit. I see the rabbit in the moon.
I didn't even know there was a rabbit in the moon.
Yeah. There's a rabbit. His ears are kind of sideways, you know.
Oh, wait. There's the ears.
Those are his ears.
Okay, there's the
That's
head.
right there. And then
There's the body.
And his
There's his tail.
little fuzzy tail.
Right
over
there. Ah, learned something new today.
That's right. Rabbit in the moon.
There's Mr. Martin Eastburn. Let me zoom in.
Martin Eastburn, just check it out.
I'm trying to zoom. Why will it not? It won't let me zoom. No.
working against you.
It is. Darn computers. The other one from Miss Diana Herber, the Heart Nebula.
Wow, look at that.
This is where I would like to take a nice close up of. What is that? Marilat 15? Right in the middle of it?
I don't know. I
Yeah.
see this
We have it on our
beautiful
wall.
nebula.
We have it on our wall. But yeah, it's a real good shot.
Yeah. Good.
And Mr. Jim Webster
Yeah.
of Orion and the Horsehead.
Mm-hmm.
I like the way the shutters do the stars, the way that on the DSLR telephoto lens. I like the spikes
Mm-hmm.
all over. It looks pretty cool.
Mm-hmm.
This one is another Petka, and it looks like
This Virgo cluster.
Leo triplet.
Yep. Oh yeah. NGC 36, 28,
Yep.
5, and 66.
Correct.
Yeah.
It's a good picture, Petka,
Yeah.
if he's on.
He must be on.
Those are very faint, too. Very, very faint. And he's able to pick that up.
Hecka might be sleeping. I mean, we did go pretty late with that star party, so.
Which I'm surprised you're still awake, to be honest.
Well, I just have like toothpicks in my eyes, so.
And there's M5.
M5. I love looking at M5. Mm-hmm.
And then
That's
Andromeda. Yeah, that's a
all the
real good
different
one.
colors of stars in that shot.
From Craig Bobchin.
Oh, Craig.
Yep. He did
Craig
this.
started out originally with us having an AR-152,
Yeah.
and he did all this astrophotography with it, and then he upgraded through our
Yep.
upgrade program to an airspace triplet. So
I'll be darned.
that's what that is, 127 airspace triplet.
And here's Andrew Fryover with this M31.
Who's
Ooh.
Jim Fry,
And-
you said?
Andrew Fryover.
Oh, Andrew Fryover. Look at all the dust lanes, and
Yeah.
that's pretty awesome.
Yeah, I'm kind of jealous of that one.
Jealous? Yeah.
A little bit.
Yeah.
Another Mr. Mark Helton.
Running Man and all that
Mhm.
detail on Orion. Yeah. Good job.
TJ Schultz.
Yeah, the dramatic color. That's
Yeah, I
something.
like that. I'm curious if you can count the one, two, there's 4 I can see.
Oh, yeah. Got the trapezium, all right.
Another Craig Bobchin of Pleiades.
That.
That's crazy.
There's a lot of nebulosity.
It is.
Reflection nebula there. Really pretty.
Another wonderful Petka.
Yeah.
You got this one recently.
Yeah. You know, that one just looks so, just looking at it makes your whole body just like calm down.
Mm-hmm.
See that?
Indeed.
Yeah.
Lead up another Petka.
Yeah.
He does some good stuff.
Yeah.
Real good stuff.
Pekka's got his little farm of telescopes out there.
Oh, same
Another
one. No, it's the same one, I believe.
Same one.
Maybe just a double entry. This NGC 884 Lance Kennard. Is that the Beehive?
Or
Is that the Beehive cluster? Or is that the double cluster?
let's find out.
That could be the double. I just can't remember
84.
which. NGC 884.
It is I don't know. It's in GC 884.
884. Yep.
7.6 kilo light years. So 7,600 light years away in the constellation of Perseus.
Oh, it's 7 Persei.
Oh, it is the easternmost of the double cluster NGC 869.
Okay.
Okay. Yep. Double cluster, I mean, under really dark skies, it just looks like somebody poured out 2 handfuls of diamonds on black velvet. It's so beautiful. Yeah.
That's crazy. We need COVID to go away so we could start doing.
Go out
Actually-
to the panhandle of Oklahoma. There's no one around. You'll have lots of social distancing.
It's true. Another one from Mr. Hubbard
Yeah.
of the Horsehead, the Flame. Oh, excuse me.
The horse head and the flame making you tired?
No,
Oh,
you worked
okay.
me to my bone.
Wow, look at that one.
Yeah,
Look at that.
that one's amazing. I can't remember what the top one is. What is that one? But
What's
then you got what's Sagan?
what's the this is an Orion mosaic. Okay.
Yeah. Bernard's Loop, the Witch
Sure.
Head.
Yeah. Okay.
Of course, everybody knows an M42, and then the flame. Just so much detail just in the flame
Is
nebula
that like
and the horse head.
all the way up there? Is that in Monticeros or where is that?
That was Fort Davis State Park in Texas.
Fort.
Yeah.
That's where it was taken. Huh?
Yeah, Fort Davis.
It's dark out there.
Uh-huh.
Dark, dark, dark.
And then the Rayo Ocho.
Oh man, I love this.
Yeah, this was a good one. There were so many good ones.
Who did that one?
It was Robert Runyon.
Okay. Robert Runyon. All right. Beautiful. Beautiful.
And
Another
then
one.
another one from Andrew. He's at Big Bend at this point.
Andrew.
Fryover.
Okay. Beautiful shot.
He's done a lot, and and then another one,
What is that? Look at that.
the CRO in Oklahoma. Andrew as well,
Yeah. Beautiful.
and then Diana Herber, the Seagull.
Look at that. Looks like an eagle or something.
Mm-hmm. That's pretty cool. Mr. Andrew Corkill.
Yeah. Man, that Terminator. It's really cool.
Mm-hmm. Another Diana Herber from the Spaghetti Nebula.
Wow. Diana's knocking it out of the park. It's really
Yeah, she's come a long way in the past
Yeah.
4 months. A long way,
This is 4 months of work, really?
give or take. Yeah.
Dang.
Another Craig Bobchin.
All right. Nice.
Yeah, it's a real good shot here.
Look at all the I mean, if you look
I know.
at the state nebulosity out there and the
You got it all here.
all over the place.
Yeah, it's crazy.
Probably if you just kept exposing, you would totally overexpose the
Oh, you did.
water nebulosity. You probably wouldn't even recognize it anymore.
Mm-mm.
You know.
Chris Hansen with the Stitch of the Moon,
Yeah, like
which
that.
that's pretty cool.
Yeah. Creative. Whoa.
Black Mesa.
Wow.
I want to go to Black Mesa.
Wow. That's something.
Yeah.
I can see that hanging on somebody's wall. You know, big.
Yeah.
That's pretty.
That's pretty cool.
Yeah. Yeah.
Then another one from this one's in New Mexico by Andrew as well.
Okay.
This guy can produce some. I'm gonna have to ask him some DSLR tips.
Yeah, he's good.
He's very good.
Yeah.
And then Martin Eastburn
Martin.
on the moon,
Yeah.
and Mark Helton on the Whirlpool.
Yeah. Very nice.
And Mr. Andrew Fryover again.
Mm-hmm.
And where's he at? In Big Bend in Texas.
Big Bend. Okay.
Big Bend. So he's got California, the Pleiades.
Airstream out there.
Well, yeah,
They have
That
like
would've-
hiccups.
that would have been funny if he actually had an Airstream.
Mhm. Right.
And then the Witch Head from Diana Herber.
Wow.
Which the
That
Witch Head
looks
is
like a
in.
Witch Head right there, doesn't
Yeah,
it?
it does. And this one is in Orion.
Yeah.
And that's it. That's all the entries we had. We had a total of 48 entries.
That's beautiful.
It was.
All right. So out of all those entries, I guess now is the moment of truth, huh?
The moment of truth, third place goes to the Witch Head Nebula, Diana Herber, the one that we see on screen.
Very nice.
Second place is going to go to Craig Bobchin. Wrong sport. And first place,
Drum roll, please.
Mr. Andrew Fryhover with the beautiful shot of the Milky Way.
Wow,
Great.
that's great.
It is,
Okay.
yes.
All right. So let's talk a little bit about um, the prizes that they're winning and
Okay.
what it's all about. Yeah.
Well, so third place winner receives $25 gift card from Explore Scientific and an upgrade to their EA membership, if applicable. They also receive an 18 by 24 printed or mounted print of their winning image.
Very nice.
Second place is a $50 Explore Scientific gift card and also an upgrade in their EA membership, if applicable.
Okay.
Same 18 by 24 mounted picture.
Okay.
First place winner receives a $75 Explore Scientific gift card and also an upgrade on their EA membership, as well as an 18 by 24 mounted picture of their winning shot. So yeah, Andrew Fryover, Craig Bob Chin, and Diana Herber are going to have some nice pictures
Yeah. Very nice.
at their house.
Congratulations, you guys.
Yes.
That's awesome. So we've also been touting the next event
Mhm.
or the astrophotography contest being done with smartphones, right? Ta-da.
Cell phones.
So any equipment, any smartphone.
Yep.
Is there any rules?
Have fun.
Have fun. Gotta have fun. That's right.
Have fun.
Right? And so I like this, showing all the images and everything.
Mhm.
What do you think about having a vote, popularity vote by our audience? Is
Takes the pressure off of me, so sure.
Yeah, it takes, that's true.
I mean,
That's
yeah.
true.
I mean, what we can do is the day the contest ends or the next day, we can set up another live broadcast in our open go-to community that we have that Jerry's not on or Kent's not on. It's just little old me, and we can let the audience pick out of all the entrants. I think that'd be a good idea, honestly. Let's get the people involved.
I think it'd be fun. What do you guys think in the audience? You want to be judges this time?
Do it.
See by a raise of yays or nays.
Yay.
No answers yet.
Uh-oh.
Quiet out there.
Chirp, chirp, chirp.
So do we, Book Davies likes it. Jim Norwood, nice job, Tyler. You have shown great improvement in photo contest handling. Harold Locke says, sounds good. Okay. Put them on Facebook or somewhere and tally the likes.
Oh, we could do that too.
We could do that.
We could do that.
But not everybody's on Facebook,
That is true.
right?
That is
Not
true.
everybody's on Facebook. Some people don't like Facebook. Not me, I like it, but might be a camel or 20 ballots. Okay. Cameron Gillis is good. He's down for it. We'll have to figure it out.
Yeah, which we can figure it out.
Okay. No one
We can
said
do that. No, I like the idea. I am open to suggestions.
Yeah. Harold says, please post all. So yeah, we can post all the astrophotos that were submitted and then highlight the ones that are the winners. So
We can do that. Definitely do that.
very cool. All right. Well, that's awesome. Tyler, thank you very much. Thank you. Yeah. Kent has been doing the Universe Sampler from the Astronomical League, and he's got all the way up to lesson 5. And so Tyler and I are going to kind of go through lesson 5 with you. Let me go ahead and pull it up. And Kent did prepare this PowerPoint, which is nice. Thank you, Kent. And let's see.
Wherever you are on your vacation.
Wherever you are, exactly. That's right.
This is a good book.
What's that?
This is a good book.
Which book are you looking at?
The one that I can't
Oh, yes.
focus.
of course.
Focus.
Focus. Yes, we're doing
Focus.
lesson 5, stating locations of objects in the sky right ascension and declination. Okay. So now, guys, being that I have this in full screen, I can't
I can.
the chat, but Tyler can. Good.
I can.
Okay. Very
I
good.
can. I can make use of myself.
Awesome. All right. So here we go. And right there. Oh, here we go. Nice little cover there, Amelia Goldberg. And the Universe Sampler Observing Program can be purchased for as little as $13. I'm going to let you either write down this this short bit.ly URL, so it takes you right to it. Okay, and then there's the Observing Club as well. Okay, and we've posted this before, but it's a great book for $13. And you go through this. For most of you, it should be pretty pretty easy observing program to accomplish with the Astronomical League. It will give you they give recognition for completing it, which I think is awesome. So here we go. All right, so a quick review. We did lesson 4, which was angular measures of distance. And easy to measure distance is to use your fingers and hands. So you guys will know that from the last episode that 1 finger equals 1 degree in the sky. That's 60 arc minutes, okay, is 1 degree, or 3,600 arc seconds, okay? 3 fingers is 5 degrees, approximately. 1 fist equals 10 degrees. And then if you spread your little finger and your thumb or your index finger out as far as you can, that says 15 degrees, but I believe it's really your thumb and your little finger, because
I thought it was the
if you
cowabunga.
if you take your fist and measure from your thumb to your little finger, actually my fist it's just double, okay? So that would be, for me, that would be 10 degrees, okay? Some people may have longer little fingers and thumbs, but anyhow, you get the idea. You can measure the sky like that,
Actually,
also too, for me, when I put my thumb out, you remember in the famous Apollo 13, Jim Lovell was outside and he was putting his thumb right over the moon. The moon is half a degree, okay? So
I did find
these numbers
something.
need to be revised, but again, you get the idea.
I did find something. This is right. This is 15 degrees. This is 25 degrees.
So why is your fist, unless you have a little tiny fist?
I don't. Here, I'll share my screen. No, I can't share my screen. But a pinky is 1.
Okay, my
3
fist
fingers.
is almost exactly so that would be 20 degrees, okay, if that's true.
Yeah, it's 20, 25, depending on how big your hands are. Per this Astronomy Essential article back in 2021.
So is that like human DNA setting up the distance of the universe with fingers and fists and stuff?
This image was
calibrated based off your own fingers, fists, and spread
maybe
fingers.
the guy on the picture's got a very dainty hand. So,
All
right, let's
marker
continue.
in the sky, the full moon is half a degree, almost exactly. So, okay, so they cover using the horizon or the altitude azimuth system, okay? And they describe what azimuth is, and the azimuth is the horizon in a circle of 360 degrees, okay? So using the 4 main compass points, north, east, south, and west, you use those compass directions, or what's called azimuth, to state the location of an object in the sky. It's measured starting in the north, going towards the east, increasing towards the south, then back to the west, and then back to the north. So you've got, effectively 360 degrees, but it goes like from 0 to 359. Altitude is measured from any point on the horizon to the zenith, okay? So the horizon's 0 degrees, and the zenith, which is straight overhead, is 90 degrees, okay, in altitude. Then the other type of measurement, which is very common, probably more common in the astronomy world, is using right ascension and declination. This is how, if you look at star maps, there's a system of coordinates that are marked down, which basically apply, if you took the longitude lines of the Earth, okay, going from 0 to 23 hours and 59 minutes, because it's measured that way, okay? So you got these 24 sectors, okay? Take those lines, explode them out to the sky, okay? And then you go in lines from the North Pole, which would just be a point, okay? With circles going down to our equator, okay? Which, and then take those lines and go all the way down to the South Pole, and take those circles and explode them out to the sky. Now you have this grid pattern, all right? But this grid pattern is more or less it's not totally fixed, because there's something called precession, but to us, because we only live to maybe 100 years old, okay, which is not very long, we see objects basically in the same spot our entire lives, and so will our children and their children's children. And if we look at old star charts from hundreds of years ago, things pretty much look the same, okay, as far as where these objects are pinned against the sky, okay. In fact, you know, all stars and everything's moving out there. It's just that they're so far away that we don't get that from looking at it with the naked eye. If you're going to make a map and try to pin down exactly where these celestial objects are, galaxies, nebula, these types of things that are more or less, I'm not going to call them fixed, but apparently fixed, okay, in the sky, the right ascension declination system is more useful to you, okay? It also works out extremely well for equatorial mounts, where you have an arc that is in right ascension, okay, and stars appear to ascend to the right, you know, east, rising off the east horizon. That's the reason why it's called right ascension. And if you were looking at the north or south pole in the sky, in going any direction away from that, you are declining away from the pole. So that's the reason why they call it declination, okay? This is great for making star maps and finding positions of objects in the sky, so that you can plug in coordinates based off of that, utilizing any telescope that is aligned to this coordinate system, and it's going to go find it, okay? Whether it's setting circles or go-to system. The alt-azimuth is probably most useful for times where we have something moving across the sky, and knowing your position on Earth and what time it is that you saw it is more important than the right ascension and declination of that object. Because let's take a comet, for example. It's moving across the sky. Sometimes you can actually watch it moving, you know, quite quickly over the course of even one night. So, you know, if you're making a careful measurement of that, the alt-az position of it, where you are on Earth, where you saw it is more critical. This also becomes very critical if you are making a report of a meteor streaking across the sky. So if you're someone that likes to report that, knowing the altitude azimuth coordinate system is more useful, okay? So both of them are used, but you know, it is the RA and DEC that is more used in the astronomical world. These illustrations here show the lines of declination. They look like, you know, to me, they look like big hula hoops going across till we get to the equator. When you project it out against the sky, that becomes our celestial equator. So we have the north celestial pole, the south celestial pole, and these parallel lines of declination, okay? When we go to looking at the altitude, you know, this is showing altitude, but expressed in declination here. So if we are at 30 degrees latitude on the Earth, okay, then you can see how that how that changes, okay. So your North Star is at plus 90 degrees, which it looks like it's about 30 degrees above the horizon there. Your overhead deck is 30 degrees deck, okay? And then looking down towards the south, we can see about down to minus 60. So you can see roughly 70% of the sky, okay? You know, if you are almost anywhere on Earth, well, that's not entirely true. If you're down about the latitude, the mid-range latitudes, you can roughly see about 70%. If we went to the North Pole, it would be a different story, or the South Pole. Then we've got, let me go back. Let's go, how do I get back? Here we go. There we are. We go back to the lines of right ascension. They look like longitude lines, okay, projected out onto the sky. And they range from 0 hours to 23 hours and 59 minutes and 59 seconds, okay? With the lines of right ascension, if we are at the 0 longitude line on Earth and we see the 0 longitude or right ascension line pass directly overhead, then that means that it is 0 hours UTC or GMT time, okay? And that's how we initially set time for the world. So understanding you know, how the connection of stars passing overhead and how that sets time for us here on Earth is very important. Kent points out in this little part here that the equinox is the point where the sun crosses the equator as it goes from the southern hemisphere to the northern hemisphere. That happens about March 21st. Right ascension increases towards the east, going completely around the celestial sphere, back to the starting point of 0 hours. There is no 24-hour circle. It goes to 23:59. The hour circles measure the distance in time of any object on the celestial sphere from the vernal equinox. He goes further to say that most star charts use the right ascension declination system as shown in figure 9. I've never used a star chart that was in alt-az. I've had computerized star charts where you could find the alt-az of an object in the sky, okay? Again, probably most useful for reporting a moving object across your location. So if you know your longitude, latitude, you know the alt-az of the object in the sky, those numbers help really pin down exact position of a moving object if you're recording that. So, and if you look at star charts will show the lines of degrees of declination. This is a standard type of star chart, maybe like a Norton star atlas or a Wilterian star atlas would be like this. So on the left-hand column there, you see degrees of declination. So this is, if it's got plus in front of it, you know you're in the northern hemisphere. If it's got minus in front of it, you know that you're in the southern hemisphere constellations. And then along the top, it shows the hours of right ascension. So you can see that that's listing 22 hours, 20 hours, and 18 hours right there. My Sky Atlas 2000 has a plastic overlay that allows me to match up the lines and to get the incremental hours of right ascension and declination. So very cool to have that. And the review is that right ascension is like longitude and latitude, or longitude on the ground. Declination is like latitude. And just like every single point on Earth has an exact longitude and latitude address, every spot in the sky does too, but that address uses right ascension and declination, except for moving objects, okay? But you could pin down RA and DEC for, which is what right ascension and declination are commonly called, is RA and DEC for an object as well. And I think that's it. So the next lesson is going to be about star hopping. You know what I'm finding, Tyler? If you're still there, maybe you're not still there. What I'm finding is, is that.
No, I'm here. I'm
Are
here.
you?
I'm here.
Are you, Tyler?
I'm here. I was in the abyss.
You're
I was
under
here.
the dust. Okay.
No. Catching up on sleep.
Star hopping.
Sleep.
A lot
sleep.
of people have lost or have never learned how to do star hopping. You know,
To be honest, I've never.
you never star hopped, huh?
My old mentor, and he's still a mentor, tried to teach me how to star hop, but
Mhm.
me being a child and not being patient, no.
Oh no.
Yeah, but I kind of know how to do it, but doing it with a big eyepiece, like a 40 millimeter or
Yeah, you
a
do it
30
with
millimeter.
typically.
Oh, it's just to see all those stars just there in the field of view. It is spectacular to do.
It is.
Yeah, I need to learn it. I definitely do. But
I've known some remarkable people, astronomers that knew how to star hop to hundreds of galaxies in a night. That was Reverend Evans. He discovered, I think, over 20 supernova in galaxies. And the dude was a machine. He just knew how to push the telescope, to get to
That's
all the
crazy.
galaxies. And he could do about 600 galaxies a night.
Holy moly.
A guy named Joe New, who was a sales manager, I believe, for a company called Coulter Optical. Coulter Optical sold a very popular Dobsonian called the Odyssey. And I had an Odyssey 13-inch telescope. That's what I learned on. But this guy, I don't know how he did this, but what he would do is you would be behind the telescope, kind of looking up towards the sky. He would be facing you, okay, looking at the ground, holding your telescope. He would ask you what object that you were looking at. So let's say you were looking at M13. He'd go, okay, well, here's M92. Here's this. Here's that. Here's the double.
Wow.
Double. Here's, and he would do like that. And all these objects would, not in a high power eyepiece, but in a medium power eyepiece, he could do this just by movements of his hand. Okay.
God, it's so long.
It was crazy. But the thing that's interesting about star hopping is it is a kind of organic way to learn the sky.
Oh yeah.
And I kind of put it, if you learn how to star hop and you learn how to draw the eyepiece, okay, you improve your understanding of the sky at large, and also you learn how to observe extremely well. Okay, so you start making drawings on a piece of paper, and you already got a big circle already drawn out.
Yeah.
And I think that the Universe Sampler actually has sample pages for
They do.
recording like that.
They do.
Right, and so and even if you're not an artist, if you start making these, putting the pencil down where you think that you're seeing detail, and then you go back and look at photographs, a lot of times you'll find out you saw detail that you didn't think you saw. Okay,
Yeah.
it's very interesting.
Yeah. When we did the last star party for Stars and Sauce, Kent was just out there with a laser, just going to town. It's like, this is where this is, this. Like, where are you at? It's like, where are you at? I don't know where you are. Slow down for 2 minutes.
So all those people out there that have devoted themselves to learning astrophotography, I would recommend that you get your astrophotography rig totally set up with scripting. Okay, get it all set up, script your stuff for the night, and then get a Dobsonian telescope with maybe a Telrad on it and a wide field eyepiece, and learn how to star hop. So I think you'll find it very enjoyable.
I agree.
Anyways, that's our program for tonight. And
It's already nighttime? No.
yes.
I've worked here that long? No.
Yes, it's time to say not goodbye, but see you later. Okay.
See you all around.
We will be back, and thanks for watching, everyone. Congratulations again to the winners of our astrophotography contest. Be sure to brush, wipe down and clean up the lenses on your smartphone and start making some beautiful images. Look online onto the app section, you know, whether it's the Google Play Store, if you got an Android, or the Apple Store. There are apps designed for astrophotography, and so you might want to download some of them and start playing with it. When will we start this? Or maybe, well, I guess we're already started. When will we end the next astrophotography contest?
We haven't officially started it, or have you said things that I have not been told about?
Go.
Yeah, there it is. I think we need to keep this one open
Because
for
they
a
can
while.
use old images, right?
I think honestly, with Milky Way season coming up, I think we honestly need to keep this open for what, 2 months?
Yeah.
How's 2 months sound?
That'd be
2
good.
months?
That'd be good. Give them enough time, you know, pending cloudy skies and all the rest of it.
So how about we start? not today, because we don't have everything set up for it yet. Let's start on Monday, the 29th.
Monday. All right. We'll start collecting images on the.
Correct.
You can go now. Okay. You can start.
Okay, yeah, go now. Take pictures.
Go collect your old images. You know, I'm sure.
Yeah.
I know Wiesner's got a bunch of them. So.
Yeah, but he has to use brand new. I won't accept anything.
Brand new.
Sorry, Mike. I can run a database and figure it out.
I see. That's right. You'll hack into his phone and check out the photo log.
There you go.
All right. Okay. Well, thank you very much. And you guys keep looking up. And as always, it's a pleasure. And we will see you tomorrow with the Open Go-To community. Bye. These are Explore Scientific's Trust Tube Dobsonians. We have a 10-inch f4.5, a 12-inch f5, a 16-inch f4.5, and this massive 20-inch f3.6. All of these telescopes can be completely folded down so they'll fit in the back seat of a small vehicle. So you can take them anywhere. We do recommend for the 16 and the 20 to have somebody help you lift it out of the car because a lot of optical weight there. So let's go over some of the features. We're going to talk about the 2-inch 2-speed focusers on which models again, Ken?
The 2-inch 2-speed focusers come on the 10-inch, the 12-inch, and the 16-inch.
How about this one?
The 20-inch comes with a 2.5-inch 2-speed focuser. Rack and pinion, they're all rack and pinion focusers.
So real smooth, right?
Real smooth.
Real smooth. Now, also these telescopes have large oversized bearings, okay? So that you got a real smooth adjustment for every Dobsonian needs. We captured the knobs so that you don't lose knobs out in the field. But let's talk about some of the other features. How about collimation?
Collimation of a big Dobsonian, any Dobsonian really is tough because you have to have 2 people. This design includes this little tool right here, which is very simple to put down into the focuser.
Yes, our magic wand.
Into the focuser, into the secondary, the magic wand.
Yes.
And collimate the telescope by yourself.
By yourself.
Which is huge.
That's the magic.
Additionally, they come with counterweight as accessories. You need counterweights, and they come with a in and out fan so you can get your mirror cooled down to ambient temperature.
That's right. So comes with a little battery pack as well. You'll also get a shield that will block out stray light from the eyepiece cage area.
Hi, I'm McGee Cox, a spacecraft operations engineer. I've been lucky enough to work for U.S. Space Command in the commercial space industry as well, and now I'm at NASA's Jet Propulsion Laboratory working on the Mars 2020 Perseverance rover. Don't forget to visit NEAF, the virtual experience, April 10th, 2021. It's the world's largest space and astronomy expo. Go to neafexpo.com. I hope you have a great time.